Right, ooh, sorry about that. There you go, that's better. Righto, guys. I'm just going to pick an example from the bearings exercise from chapter 3, and I'm just going to work through that for you, just to give you a bit of a taste about how these things go. So I'm picking question 14. Just zooming in on it here so I can see it a bit clearer, because righto. So question 14 tells us that a hiker walks on a triangular pathway starting at point A. It gives us this diagram here. That's north. There's point A. It says he walks to point B on a bearing of 140 degrees. And then he walks to C. And the angle in here, we're told, is 75 degrees. Okay, then the question says, find the bearing from B to A. Now, look, these words, these are little tiny words that come up in bearings that people have trouble with all the time. And it's the words to and from. Okay, so the question says, find the bearing from B to A. So from B to A means here I am at B. And it's asking me what angle do I need to turn through to be facing point A. Now remember with bearings that we always turn, starting from north, we go clockwise. Okay. So what the question is asking me is, what angle am I turning through here? What is that angle there? Well, we need to make use of a couple of the relationships that we see on the board in front of us. If you have a look at this, see that line there is also pointing north. These two lines are parallel. Given that they're parallel, that means that the angles here have got a particular relationship between them. Okay. They're actually co-interior angles. Now remember the relationship for co-interior angles. Co-interior angles are supplementary. Do you remember what supplementary means? Supplementary means they add up to 180. So this angle in here and this angle here add up to 180 degrees. So let me call this angle here theta. So I know that theta is 180 minus 140 degrees. I should give a reason. I should never just state these things. Never ever with geometry just state something. Always give a reason for what you're stating. The reason is because co-interior angles are supplementary when lines are parallel. Okay, so that means that theta is 40 degrees. Okay, well remember I needed this angle here. I needed the angle from north going all the way around to here. Well, of course, now that I know that's 40 degrees, well that angle there, that large angle, the big reflex angle, is going to be 360 minus 40 degrees. So the bearing from B to A. Now, another way to write that, so don't let it rattle you. Another way to say exactly the same thing is to say the bearing of A from B. So both of those things are saying exactly the same thing. Don't let the wording in different questions throw you. Okay. So you don't need to write both. I just wrote both for you. The bearing of B from A to B. Goodness gracious me. The bearing from B to A is 360 minus 40 degrees. And if we want to give a reason for that, it's because the angle sum of a revolution equals 360 degrees. So in other words, the bearing is 320 degrees. That's the answer to part A. Okay. Then it says find the bearing from B to C. From B to C. So they're asking now, I'll just change colours. They're asking for this angle here. So from B around to C. From B around to C. Okay, well, let's put together what we already know. We know that theta in there is 40, and we know that this is 75 degrees. So the angle from B facing north around to C is going to be 360 minus 40 minus 75. Okay. So the bearing of C from B is 360, or we maybe say it's 320 minus a 75, it doesn't matter. 360 minus 40 minus 75 for exactly the same reason as there. What have we got? 320, 250, 245, unless I've made a mistake in my head there, but 245 degrees. Okay, check that with your calculator. I just did that off the top of my head. Then it says find the bearing from C to B. Okay, so this time it's from C to B. So now they're after this angle here. Okay, so they're after that angle there. Well, look, let me complete something for you. We know that's 140 degrees up there, and this is a straight line. So this angle in here is going to equal 40 degrees. This angle here is 75 degrees, and the angle sum of that triangle has to add up to 180 degrees. Okay, so let me call this angle down here alpha. And so I'll just give myself a little bit of board space. So alpha is going to equal 180 minus 40 minus 75. And the reason for that, of course, is because the angle sum of a triangle equals 180 degrees. And so we've got 65 degrees. Do we have that? 105, take away 40, 65 degrees. Okay. Then part D says if the initial bearing was instead 133 degrees, so let me redraw the diagram now. Okay, so if the initial bearing was instead 133 degrees and angle ABC is still 75 degrees, find the bearing from B to C. From B to C. So again, they're asking for this angle here. We're just going to go through the same process. I need to find out this angle in here. So that angle in there and that angle in there are co-interior again. So last time we had 40 degrees here. This time we're going to have 47 degrees. Well, exactly the same argument that we had the last time through. And so this angle here is 360 minus 47 minus 75. Okay, that'll give us that. I'll leave you to do that calculation. and then it gives us another variation of exactly the same problem. It says if this was 140 degrees and that was 42 degrees, what would happen now? Again, I'll leave you to go through that. That's just more sort of turning the handle. So guys, that's actually the last problem in the development section of exercise 2J. It should, I hope, bring you up to speed with everything you need to do for all of that bearings exercise. After this, all that's left to do is the chapter review. I'll leave you guys to do the chapter review. Please don't have anything in the chapter review that you're not able to do. If there's any problems at all, either drop a comment below here or go over to our Microsoft Teams page and drop a question in there, and I'll get an answer to you just as soon as I can. Thanks, guys.